Hello students, today we are in lecture number 11 of chapter 1 Electrostat. This is S Pandey. Today's student will study, as I told you, about the electric dipole. Electric dipole, and then we will draw the electric field lines for this electric dipole. The meaning of this electric dipole, it is dipole means the two pole. Actually, we are studying here. In simple language, in your notes, if in examination it is coming, what is electric dipole, then you can write a system of two charges having equal magnitude and of opposite nature, separated by very small vector distance, is known as electric dipole. This is the simple definition, my dear student. Now, how this electric dipole form, we'll try to understand. What is this electric dipole actually? It is the system of two charges. Suppose here the plus and here the minus charge. And this system, if the very small distance, vector distance r. So such type of system, this system is called dipole. Which type of dipole? Electric dipole. We'll study in other chapters later on about the magnetic dipole also. Here we are talking about the electric dipole. If it is plus q, it is minus q, the two charges separated by very small vector distance. Here the center of mass separated by very small distance. Here r, the system is called electric dipole. We have been studied electric dipole. Suppose a student will, if I will ask what will be the net charge of this system, what will be the answer? Answer is 0. Of course, for the system of dipole, the net charge of dipole must be 0. Now, how this electric dipole formed? Formation of electric dipole. When center of mass of two atom, having opposite nature of charge are separate, plus and minus, separate, they form, when center of mass separate, okay, they form what? Dipole. Which dipole? Electric dipole. But for the two atom, if the center of mass coincides, it is plus and minus, the center of mass coincides, they form actually neutral body, but not the electric dipole. So this is a very simple concept of formation of electric dipole. If you will ask, then you can give the answer. Now students, if I'll leave a question, try to find out the answer by yourself. As we know that the net charge of dipole must be 0. Now the question is, can we have net field at any point around this dipole, in between the dipole, anywhere? Can we have net electric field 0 due to this dipole? This is your question. Okay, try to find out the answer. If I'll give you the answer, it would be very easy for you and you will not do any exercise. So try to find out the answer. Can we have net field 0 at any point around the electric dipole? Now, few important points, student. Noteworthy point. This is the dipole of positive charge and negative charge. While the calculation, if we'll do the calculation for electric field due to this dipole, we will consider, remember, we will consider the separation between the center of mass of this dipole, since this distance is very small. Remember, for easy view, I am drawing here these two charges at very large distance. Otherwise, the separations would be very, very small. Okay. Now, this distance usually we take for easy calculation as I have been written here, the R. This will be taken as 2R or 2L or 2A, whatever. Okay. 2R as a vector distance. Why? So that we can divide this dipole from its center as R and R. Don't be confused. If I am taking this distance as 2R, there's nothing for very much discussion. Why, sir? Why we are taking here the separation between these two charges 2R? Is there any very big concept behind this 2R? Actually, answer is no. There's nothing very much for discussion behind this 2R. For simplicity, for easy calculation, we are taking here 2R. Okay. Now, the two charges we have in place as dipole. This is plus and this is minus. This axis, which makes the center of mass of two charges of dipole, center of mass of two charges, the axis, that is the line joining the two charges of this dipole, is called axial line. Okay, it is called axial line. And any point you will consider on this line over here, will not consider in between these two charges for calculation. Why? Because this separation is very small, very small. Okay, so we'll take the point outside the dipole. This point is called, this is axial line. Okay, this is the axial line, and this point is called axial point. Axial point or end on position. End on position. Okay, because we have been taken this point at end of either charge, either negative or positive. So this is called axial point or end on position. And the next point, the line we have been drawn perpendicular bisector, okay, from the center of this dipole. This line will be considered as equatorial line. Equatorial line. And any point above this line, in geography you have been studied the equatorial plane. Okay, so this is the equatorial line, and the point over this equatorial line is considered as equatorial point. Equatorial point, okay, or broad on position. Broad on position. Okay, equatorial point or broad on position. There will be two name, and for this two you will be asked to find the electric field. There will be another point that is a part of this axial and equatorial. Suppose at any point here we are considering. Okay, so what we'll call this point, if it is angle theta, this is neither 90 degree nor 0 degree and not 180 degree even. Okay, so this point will be considered as arbitrary point. Arbitrary point. Okay, so you may be asked to find the electric field due to dipole at axial point or inbound position. You may be asked to find electric field at equatorial point, over the equatorial line, equatorial point or broad on position, or you may be asked to find the electric field at any arbitrary point, and this will be given. All the data will be given, just you will have to find the electric field. Now student will study about the electric dipole moment. Okay, electric dipole moment. Electric dipole moment. This electric dipole moment we will represent by P, and this is vector quantity. That's why we will put a vector sign over here. Remember, this will have magnitude as well direction. It is very interesting to find the direction of dipole. Okay, or the dipole moment. So electric dipole moment will be the physical quantity. We'll study what is this electric dipole moment. You can write a student as to make your notes. Electric dipole moment. Electric dipole moment is the product of magnitude of either charge. Since both the charges are of equal magnitude while making the dipole, so it is the product of magnitude of either charge. Product of magnitude of either charge. This is the simple algebraic multiplication, not the vector symbol. So the Q times the separation between two charges. Okay, the vector separation between two charges, and this will give you the mathematical concept of electric dipole moment. Suppose this is the charge Q, then another charge it is minus Q, and this is the small vector separation between these two charges as R. So the electric dipole moment you can write here, the P is equals to Q. It is the magnitude of either charge. Here Q and Q are same, Q times R. Usually you will find the definition or the mathematical formulation written in your book in this way. As I told you, for simple calculation we'll write this distance from the center of two charges as 2R. Okay, 2R. So you will find the P is equals to Q times 2R. Again, I'm telling you, there's nothing for the great discussion about, sir, why this is R, why this is 2R. Sir, it will change the value of numerical calculation. Okay, students. So, for example, let me play a few examples. Suppose the 5 picocoulomb. Pico means 10 to the power minus 12. Here the plus 5 picocoulomb and another minus 5 picocoulomb. Okay, this is minus 5 picocoulomb. It is separated by 10 angstrom. 10 angstrom. So you can say this is a dipole, and the answer is yes, correct. This is a dipole. Now, how many dipoles you can see over here? Exactly here we are having one dipole. Okay, now here 5 picocoulomb, 5 picocoulomb, and another plus 5 picocoulomb, and here minus 10 picocoulomb. The separation here 5 angstrom, here 5 angstrom. Now again I'm asking the question, how many dipoles are there in this system? How many dipoles are there in this system? And the answer is, here we are having how many dipoles? 1 or 2? The answer is, here we are having 2 dipoles. One dipole, the 5 picocoulomb will form with the 5 picocoulomb here with the negative, and the rest 5 picocoulomb negative will form the dipole with this 5 picocoulomb. Okay, student? So in this way you will have the number of examples to find how many dipoles are there and how you can find the net dipole moment. Now student, you can find the dipole moment easily, no doubt, I know. Here as we know that the electric dipole moment is a vector quantity. If I am giving you to find the net dipole moment, before we should understand about the direction of dipole moment. Okay, we have been studied the magnitude. What is the magnitude? Magnitude of dipole moment is the q times 2r. Okay, q times 2r. This is the magnitude of dipole, electric dipole moment. Now I'm asking the direction of, this is the magnitude of, not the dipole actually, this is the dipole moment. Okay, now I'm asking the question, direction of dipole moment. Since student two charges, try to draw the electric field. This is the electric field. Okay, now the direction from positive to negative, from positive to negative. Okay, but we know that, of course, this is dipole. Am I right? Yes, it is dipole. But we know that for dipole, this separation between these two charges should be very small. In fact, dipole moment, the direction of dipole moment, we cannot find exactly by the direction of electric field, but for the system on the axial line, we used to represent the direction of dipole moment using the field of dipole moment. If these two charges will be very near to each other, then what will happen? This field lines will vanish off. I mean, you will be not able to see, actually to visualize. Now we will just make these two charges very close to each other, then what you will find here? You will find it is positive and it is negative. In between these two charges, I am not able to draw the field lines. Then here I will draw the field lines out of the dipole, and out of the dipole here you can see the field out, here the field in. Now you can see the field, it is moving from negative to positive. Okay, this will be the trick to remember the direction of dipole moment, from negative to positive. Okay, so the direction must be taken, taken from negative to positive. Kindly write down in your notes the direction must be from negative to positive. Okay, if we are having here the 5 microcoulomb and another charge minus 5 microcoulomb over the x-axis, then what will be the direction of dipole moment? So at any point the direction of dipole moment you can represent from negative to positive, and you can find the, if it is 10 angstrom and you have been asked to find the magnitude and direction of dipole moment, then you can solve the direction and magnitude. The magnitude will be q, it is 5 times 10 to the power minus 6 into the separation between these two charges is 10 angstrom, 10 to the power minus 10. Okay, what will be the SI unit? The SI unit will be, since it is q times r, that is the coulomb meter. Okay, coulomb meter, remember, coulomb meter, and the direction will be, if you put here as a magnitude the vector quantity, so the direction will be along I cap or minus I cap. Of course the answer will be minus I cap, from negative to positive, so it is minus I cap. Okay student, now let me take another example quickly. Here plus q minus q minus q, and in the charge it is placed minus q, so it is a plus 2q at pi by 6. You have to find the net dipole moment. Okay, net dipole moment. Kindly solve student. Okay, look at here. This is the from negative to positive one dipole moment and another dipole moment in this direction. Here the P1 and P2 at which angle? Pi by 6, that is 30 degree. Okay, here the P2 and P1 at 30 degree. P1 is nothing but the separation, you can see here the R and R. So the P1 is Q times R and this P2 is also Q times R. I'm writing here the Q times R, the magnitude. So the net dipole moment will be root under P square plus P square plus 2P square and cos 30 degree, which is root 3 over 2. By putting this value you can solve this one. Okay, now another simple question I'm asking, and this will be your home work. Minus 5q at r distance plus q at r distance plus q at this r distance plus q, and here at r distance plus 2q. This all the distance are very small, these charges are very small, they are kept very near to each other. Now the question, the very simple question you have been asked, how many dipoles are there in this system? Of course, students, if I'll give you the angle between these all the positions for this charge, then you can find out the net electric dipole moment for this system also. So this is not very tough for you. Now students, this is all about the today lecture. In next lecture, since already we have been taken the last time to understand this electric dipole moment, and it was a very important topic, in next lecture, student, we will try to understand about the electric field due to dipole at equatorial and axial point. And one point another, student, since we are having few minutes, let me explain today itself, otherwise next day we'll have the very important topic. One thing, remember student, about the equilibrium of dipole. Okay, this type of question will be asked in your board examination. Equilibrium, I'll take you 2 minutes more. Equilibrium of dipole, not the very tough topic. If we will place a dipole, and if we say that a dipole in stable equilibrium, what does it mean? Actually, for the stable equilibrium, of course, for stable equilibrium, I'm talking about stable equilibrium. Okay, remember, first point, net force must be 0, and the second, net torque will be 0 in a stable equilibrium. If we are talking about the stable equilibrium, then net force must be 0 and net torque must be 0. That is, if you will disturb this dipole, a restoring force will act to regain the stable equilibrium of this dipole. Okay. Now, in unstable equilibrium, try to remember, in unstable equilibrium, the net force must be 0. Again, net force must be 0, but net torque not will be equals to 0. This is the meaning of stable and unstable equilibrium. If you can draw the stable and unstable equilibrium, I will be very happy. Try to represent this stable and unstable equilibrium of dipole as your class work. Okay, draw. What do you have to draw? Actually, this stable and unstable and stable equilibrium. Okay, and the last point about this, if field is uniform, remember, if field is uniform, then dipole perform only rotational motion about the center. Okay, about the center. Remember, kindly note down, in uniform electric field, only rotational motion. Okay, rotational motion will be performed by the dipole. In non-uniform electric field, what will happen? In non-uniform electric field, the dipole will have two types of motion. It will rotate and translate. Remember, it will rotate and translate. In uniform electric field, it will rotate. If it is rotating, then it must have some torque, this condition. And in non-uniform electric field, it will rotate as well as it will translate from its actual position. So that's it about the today lecture, students. Thank you very much.